So I've now got lots of parts of my graph. I'm going to add in here a 0. So there's a 0 at 0, 0, and I can determine that based on the numerator of the original function. And I can see in the numerator, I have a 0 factor and a -1 factor. It can't be -1 because we know that that is a restricted value. So I have vertical, horizontal asymptotes. I have my left-handed limit for my hole and the right-handed limit for my hole. And I don't have any min or max points because if I take a look at my slope charts, I don't have any 0 slope points. So I can sketch in this graph. So I'm going to follow my asymptote here. So I'm going to follow the horizontal asymptote from the left to the hole. Okay, and then from the right, I'm going to follow from the hole. I'm going to go through my 0 and I'm going to go up to my vertical asymptote here. On the other side of that vertical asymptote, I know it's coming down. And since I have no other min or max points, I know that it just curls to the right. And there's my graph. So some keys to this, there are domain parts that we have to be aware of, our negative and positive domain based on the absolute value function. So it's important that we keep track of the domain boundaries. So we have different functions depending on which part of the domain we're working on. Okay, so we have to be aware of that. So if I were to highlight this in green, the green domain is going to be this part and this part here. Okay, and then the red domain is going to be the part in the middle. So we have to keep track of which domain we're working with, and we have to be aware of the domain boundaries because things are happening at the domain boundary. In fact, in this case, we have a jump discontinuity happening at that domain boundary. So this is one of the new interesting features then that we have analyzed. This is new. We haven't really seen this before, but this is how we can analyze this jump discontinuity at x equals -1.